of a quadratic we're solving. So I like what Tyler did. He was telling me I tried to factor it. So we look for what multiplies to be positive 10 and adds up to be negative 6, right? So do you see any factors? Nope, you're right. I don't see any factors. So this one's not factorable. So then I say, okay, if it's not factorable, I'm going to solve using the quadratic formula, because that always works for quadratics. So I know my a value is 1, my b value is negative 6, and my c value is 10. So I'm saying, okay, x equals the opposite of b, which will be positive 6, plus or minus the square root of negative 6 squared, b squared, minus 4 times a times c. I need to recalibrate. My pen's not writing where I'm writing. All over 2 times 1. So I say, okay, I know x is equal to 6 plus and minus the square root of, you'll calculate that piece, right? What'd you get? You got negative 4. Awesome. So negative 4 all over 2. So this is where you go off to the side and say, what's the square root of negative 4 equal to? 2i. Is everybody comfortable with y is equal to 2i? Okay. So we have x is equal to 6 plus and minus 2i all over 2. Then you look, do all three things divide by something? Yeah. They all divide by 2. It becomes a 1, and a 3. So we have x is equal to 3 plus and minus 1i. So I'm just going to write i, and divided by 1. Is anything divided by 1 just itself? So this is the answer you'd write. 3 plus and minus i. How many got 100% right? Way to go! You guys are awesome. How many of you just made a little error? Next time you won't make it. Awesome. That's just as good. Okay, good job. So we're going to be dealing with properties of exponents today. Super important stuff in secondary 2. One of the biggest things I've seen from my secondary 2 students coming into secondary 3 is they are not prepared in this area. You guys will be prepared. So we know all these properties of exponents. Any base to the 0 power is equal to 1. Not a to the 1, right? Not a to the 1. The whole thing becomes 1. And then we know if we have a negative exponent, we can flip it over a fraction, and it becomes a positive exponent. Now we're at the level now where we're not going to write a negative in the bottom, right? Because we've made those mistakes and we've learned from them. Okay, if you multiply the same base, you add your exponents. So you would do n plus n. When you're dividing the same base, you can subtract your exponents. You always subtract the top from the bottom in that order, so n minus n. And then if you have a base that's raised to a power, and you're raising it to another power, that's when you multiply the powers together. Don't get these two confused. That seems to be where the most confusion comes in. Okay, so let's go ahead and practice. All my problems are going to come right off your worksheet here. So, number 4, we have 10 to the negative 4 times by 10 to the 4th times by 10 to the 2nd. It just says rewrite it with one base. So look, don't we have the same exact base? Yes, base 10, right? So because we have the same base and we're multiplying the same base, we can combine this, simplify it by pulling it together with one base using the correct properties of exponents. Because we're multiplying, we add our exponents. So we have 10, negative 4 plus 4 plus 2. So we have base 10 to the negative 4 plus 4 is 0, and then plus 2 is 2. So base 10 to the 2nd power. Yes?
Do you want us to like simplify that more to like...
So it would depend on the problem, but this one just says rewrite as one base. We've accomplished that, so we're good. We'll stop right there. Which 10 squared we could write as 100, but, you know, like I said, it just asks us to rewrite it as one base. Could you do that with 2 to the 3rd power times 10 to the 3rd power? Could you combine those?
Yeah.
No, absolutely not, right? And you couldn't say 2 times 10 is 20 to this, you know what I mean? Those are the same base. You simply can't combine them. Now that doesn't go to say we couldn't simplify that. We can calculate 2 to the 3rd, write that number. We can calculate 10 to the 3rd, write that number, and then multiply them. But we simply can't combine these together. Okay, number 9. So we have negative 5b to the 3rd times negative 3b to the 6th. Now look, isn't it multiplication?
Yes.
Now we know multiplication order does not matter. This is all just being multiplied. A lot of people still, but I'm hoping you're getting more comfortable, know that negative 5 is not connected to b cubed. It's just a multiplication sign. So these parentheses are kind of there to throw you off. Okay, so we're multiplying these things. Because it's all multiplication, we can rewrite it in any order. So I put my numbers by each other. Negative 5, I cross it out so I don't miss anything, times negative 3. I'm reordering it. Times b to the 3rd, and then times b to the 6th. Same exact thing, just different order. We can do it because multiplication you can reorder in any order, and that's fine. So then multiplying it together carefully, negative 5 times negative 3 is positive 15, yeah? And then we're multiplying the same base. So this is where we add our exponents. So we'll have b to the 9th. And we're done. No negative exponents, nothing to fix. There's our answer. Now, I hope you guys are seeing like, wow, I really have come far because this was really, really hard for you. This is what we learned the first week of school and a lot of your minds were blown. But today it's feeling pretty easy. So recognize how far you've come. Okay, another one. Number 15. It looks a little bit more advanced, but we're at the level that we can do stuff like this. Now look, aren't we just multiplying all this stuff on 15? Yes, right? So can't we just reorder it in any order?
Yep.
So I'm going to go ahead and make sure I cross out everything and reorder it in every order, not missing any signs, nothing. All right, so I have a 12. I'm going to put a 12. I have a negative 1, don't I technically right there? So I have times negative 1, took care of the negative, and then times 2. I'm just reordering it. Now I have an m to the first power. I have an m to the third. And I have an m to the first power. Now guys, it doesn't hurt to just write out your work a little bit and then not miss it. It's almost worth it. And then we have an n to the first power, an n to the negative 2 power, and we're multiplying all this stuff. And then we have a p to the 5th. Now we'll just simplify it. So 12 times negative 1 times 2.
Negative 24.
Negative 24. Then we have all these base n's. Now, if you forget to write the 1s, you usually forget that that does have a 1 and you'll miss it. So we're multiplying the same base, so we add our exponents. 1 plus 3 plus 1. N to the 5th. Good. And then right here we have base n's. We're multiplying, so we add our exponents. N to the 1 plus negative 2.
Negative 1.
Negative 1. So we have n to the negative 1, and then we have a p to the 5th. Now you would look. My answer cannot contain negative exponents. Negative numbers are okay, but negative exponents are not. We have to fix them. So we draw our line, we flip anything with a negative exponent over a fraction, but then it becomes positive. So I'm going to rewrite this all pretty. So we have a negative 24 on top, that got to stay, an n to the 5th on top, that got to stay, a p to the 5th on top, and on bottom we have n to the positive 1, so I'm just going to write n. Is everybody comfortable with that? Really, really advanced problem, but I guarantee you that you're feeling more comfortable than you did week 1. Okay, good. Questions on that? Okay, so do 1 through 15, and then if you get past that, that's fine. I'll bring you back to me and do a couple more in a second on the next part, but get them, we'll have plenty of time to go back. So on number 17, if you read it, it says the area of land that Rhode Island covers is approximately 1.5 times 10 to the 3rd square miles. The area of land that Alaska covers is a little more than 4.3 times 10 to the 2nd times the land area of Rhode Island. What's the approximate area of Alaska in square miles? So we know that Rhode Island has this area, and then Alaska is 4.3 times 4.3 times 10 to the 2nd power times greater than Rhode Island. So to figure out the area of Alaska, we know it's 1.5 times 10 to the 3rd, and then we're multiplying that by 4.3 times 10 to the 2nd power. So from here, I would not suggest typing it into your calculator. I would just do it by hand. I mean, either way, as long as you can write your final answer in scientific notation. If it starts in scientific notation, they'll want the answer in scientific notation. So this is just multiplication. That's not an x. That's just a times sign. It's scientific notation. So I'm going to multiply the like part. So I multiply those two things together because it's multiplication, and I get 6.45. Then with our tens, we have times 10 to the 3rd times 10 to the 2nd. Those are the same base, and you're multiplying, so we add our exponents. So we have times 10 to the 5th. Now you would look to check to make sure that your number's truly in scientific form. Your decimal should be after one number, and it is, so we didn't have to fix this one. Does everybody see that? But if it would have been like, for example, if we had 64.5 times 10 to the 3rd, this would not be an appropriate answer because scientific notation, that decimal is always after one number, so we would fix it. So you can do it many different ways. I usually just multiply, I write it out. So I say, I know that 64.5 times 10 to the third, since that's a positive 3, we're going to move our decimal in the positive direction. 1, 2, 3. Does everybody see that? So then that adds in 2 zeros, right? So really, this is just this number. 64,500. This is written in scientific notation. This is the physical number. But now I have to put it back in scientific notation. My decimal's over here, and I'm going to move it back to where it needs to be. So I'm moving it back 1, 2, 3, 4, right? So it would be 6.45 times 10. It was positive 3, so it's positive 4. Because we fixed it. We're just writing it properly. So hopefully that kind of helps a little bit. If you have to fix it. All right. So, number 23. It says 25 raised to the 3/2 power. So, you can just type it into your calculator, and if it comes out a whole number, then you can write that answer. So, we have 25 raised to the 3 divided by 2. You get 125. So, we get 125, which is great. But if it came out as a decimal, then you would be required to rewrite it using rational exponents as a radical and then break it down by hand. So does everybody remember how to rewrite this as a radical? Aren't roots on bottom, powers on top? Because there is one on here that doesn't come out perfectly. You have to do it by hand. So if you type that in and you get a decimal, you have to go back and do it by hand. Does everybody see how that's our root? That's our power. So really we have the square root of 25 to the 3rd power. Does everybody remember rewriting it like this? So really we have the square root of 25 times 25 times 25, right? I'm not going to actually multiply that together because I'm going to have to break it down by hand anyways. So I'm just going to start right here and start breaking it down into its prime factors. Because if we multiply it all together and then break it down into its factors, it'll come out the same as if we keep it like this. So 25 breaks down into 5 times 5, right? 25 breaks down into 5 times 5, and 25 breaks down into 5 times 5. Now we're pulling out groups of 2, right? Because 5 doesn't break down any further. So we have 2 5s we can pull out, we have 2 5s we can pull out, we have 2 5s we can pull out. Was there anything left underneath? No. So we pull out a 5 times 5 times 5, which is 125. 5 times 5 times 5 is 125. So this is how to do it the long way, and this is how to do it with your calculator. But like I said, if you get a decimal, I do expect you to rewrite it as a radical and then break it down by hand. So there is one on there where you will have to do that. Okay, questions? Okay, number 25. Looking at this, we're just multiplying all this stuff, right? So let's just reorder it because we're just multiplying all this stuff, and so let's just reorder it. I'm going to put my 3 times 2 by each other, times 2, times 3. And then I have h to the 5/2. I cross them out as I go so I don't forget anything. H to the 5/4. Then I have k to the 3/4. And k to the 3/2. Then I simplify it in sections. So right here, I'm just going to multiply that out in my calculator. 6 times 6 is 36. And then right here, I'm multiplying the same base, so I add my exponents. That plus that. So you'll have to type it into your calculator because you don't want to have to do it by hand. If you do type it into your calculator correctly using parentheses, you'll get 15/4. You add up 5/2 plus 5/4 in your calculator, change it back to a fraction, and you get 15/4. So we have h to the 15/4. And then we are multiplying the same base here, so we add our exponents. So I'm going to type it into my calculator so that I can get the most simplified fraction. And I have k to the, if you type in 3/4 plus 3/2 with parentheses, you get 9/4. And then from there, I don't have any negative exponents, so there's our answer. So don't let fractional exponents scare you. Same properties apply. Okay, are you ready to go? So I'm going to come back to these ones. I'm going to come back. So I want you to work now on problems 1 through 20, or like up through 26. Ready, set, go. Then we'll come back to these ones. Up through 26, go. So these sometimes get tricky. You will, and this is what's cool about this worksheet is really, this is how you'll see it on the end of the level test. They'll usually give you a statement and ask you to fill in how can you make it true. So we have z to the blank times z to the negative fifth is equal to z to the third. So you're looking, you're like, what value can make this 3? We have negative 5 and what value can make this positive 3? Well, you have to ask yourself, what am I doing? When you multiply the same base, don't you add your exponents? So how could we get this to be 3? What number would that have to be? 8, right? Because 8 plus negative 5 is 3. Now let's say you couldn't see that right off the bat. You could set up a statement, so you could say, okay, so square plus negative 5 has to equal 3. Right? Isn't that the statement we're looking for? Now algebraically, all you have to do is solve for square. So to get the square alone, we would add 5, right? Add 5. So we have square is equal to 8. Does everybody see how to do that algebraically? And that's what you'll want to do when you get to some of the harder problems. Does that make sense, everybody? I had to do it on some of them. Okay. So we got x is equal to 8. I mean, that box is equal to 8. All right. And then number 46. So I have 3 to the a box raised to the third is equal to 27 to the 3/2. So this is one where I kind of had to set up a true statement for myself. So first of all, what I really have here is raise a power. Okay, so we're raising both of these things to the third power, right? So this is kind of how I thought through this one. I said, okay, so I have 3 to the third power, and I have a to the, when you raise a power to a power, don't you multiply? So I have 3 times box, and that's got to equal 27 to the 3/2. Okay, does everybody see how I rewrote it? Now, isn't 3 to the third 27? So 3 to the third is 27, right? So we're not even looking at that. We're looking at how can we make this box make this 3/2. So this is where I set up my equation here. So I said I need 3 box to equal 3 over 2. And now it's just algebra to get box alone, right? So I divide both sides by 3 to get box alone. So now to take your calculator, make sure you use parentheses. You have to do parentheses, 3 divided by 2, parentheses, then divided by 3. And you get box is equal to, and we always try to ask fractions, 1/2. So this box was 1/2. And it makes sense, guys. So we got 1/2, which makes sense. It makes our statement true. 1/2 times 3 is 3/2. So does everybody see how I algebraically, though, kind of had to go through it? Made it easier on myself than trying to just think about it. Okay, awesome. So hopefully those are some good techniques to help you be able to solve these. So I just want you to know you have 20 minutes to finish the worksheet. You have 25 minutes. 27 minutes to be exact. That clock's wrong. You have 27 minutes. I need you to finish the worksheet, but getting them correct is the most important thing. So go slow, get them right.